This is the supplementary video of paper, SceneFusion, Room Scale Environmental Fusion for efficient traveling between separate virtual environments. In many VR applications, existing teleportation techniques, including instant teleportation and virtual portal technique, are commonly used to quickly teleport a user from one space to another. However, these techniques have their own limitations in virtual indoor environments. The occlusion issue during teleportation makes users hard to foresee the environment around the target teleportation point and keep the sense of direction, thus hindering the user experience. In this paper, we present SceneFusion technique, which fuses individual virtual rooms into a whole virtual environment for continuous navigation and exploration. The implementation of our SceneFusion technique contains 4 stages. Initially, 2 participants are located in separate rooms. A dividing line is generated manually or automatically in each room, which divides the room into 2 parts. Our technique will retain the part where the user is currently standing, and discard the other part. Then 2 reserved parts will be aligned and stitched according to the centers of the dividing lines. And finally, the cubic Bezier curve is applied to smooth the fusion area. For more implementation details, please refer to our paper. We further conducted a pilot user study to find the suitable fusion area width of our SceneFusion technique. At the beginning of each trial, the participant was asked to pull the controller trigger as a start signal. Then the separate rooms are automatically fused using SceneFusion, and the participant was required to walk through the fusion area back and forth and visually examine the new environment. After experience, the participant rated the visual plausibility on a 5-point Likert scale from 1, very poor, to 5, excellent. All trials were divided into 4 sessions, and trials in a session corresponding to fusion area width of 0, 1, 2, or 4 meters were set in random order. In each session, the dividing line was randomly determined within a fixed 2-meter wide region for each virtual room. To make the trials diverse, each of the 2 virtual rooms had 4 candidate settings of floor-wall texture combinations, and these textures were different between both rooms. The wall or floor texture of each room was randomly chosen from 2 candidates for each session. Results revealed that the fusion area width of 4 meters was the most preferred by participants among the candidates, which was chosen for the following studies. We then employed a progressive experiment strategy and conducted 2 user studies. In the first study, we designed a single user experiment where the user frequently locomoted between 2 virtual rooms to finish the pick and place task by searching and transporting a virtual prop to a target position. In each trial, the participant was asked to search for the virtual prop, which kept flashing and pulsating. Then the participant picked up the virtual prop and placed it to the target position in the other room, which was also highlighted by a virtual ball. When the virtual prop was correctly placed, another one then started flashing and pulsating. One trial would finish until all the 3 props in a trial were successfully found and placed. In this study, we compared our technique with instant teleportation and the virtual portal technique. For instant teleportation, a blue shining circle of 1 meter diameter was set on the floor in each room, and the participant can instantly transition to the teleportation point in the other room by standing on the circle and pressing the grip button. For virtual portal technique, a 1.5 meter by 2.4 meter virtual door was set in each room, and the participant could see and reach the other room through the portal. For our SceneFusion technique, the participant fused the individual rooms by clicking the grip button, then continued to navigate and finish tasks in the fused virtual environment. In Study 2, we designed a multi-user task to evaluate the performance of different techniques in virtual collaboration scenario. 2 participants in 2 separate virtual rooms were asked to collaboratively finish the pick and place task as fast as possible. Initially, there were some virtual props in room A, where user A was asked to search for, pick up and deliver them to user B one by one. Once user B received the prop from user A could continue to search for the next virtual prop. And user B was required to take the prop and search for the target position in room B for placement. One trial would be finished after all 3 virtual props were placed correctly in succession. We allowed each participant to specify the position and rotation of the method preset before executing the collaboration task. Before setting the presets, all 3 virtual props and targets would show up, and participants were required to observe the environment and place the preset at the most appropriate place they think. When both participants settled the presets, the connection between rooms would be established, then they were required to finish the pick and place task. This is the collaboration process of instant teleportation. This is the collaboration process of virtual portal technique. This is the collaboration process of our SceneFusion. For more details, please refer to our paper. Thank you for your attention.